just about everything on this research is based on the fact that we believe, or I believe, that this is fascia. And fascia is the protective layer that coats all your organs and bones, and your skin is made out of the same material. It's keratins and keragens and collagen, all of the fabric of life that protects you from the external surfaces of life. And this is virtually I said, looks like a piece of meat to me, but it's pretty solid. Now, that, I believe, is fascia, and this is what has led to this fabulous preservation. Now, this is what fascia in a human being looks like. And, you can see the obvious similarity here. You saw the rock, and you see the fascia, and that is what we suspect. And you see all of these little fabrics and flakes. That's the fabric of your body. It invests and holds things together and keeps them protected from the other things. So anyway, that's what it is. And you see this architecture of the fascia flap there, and you'll see that in a lot of places on our stuff. Well, while we're on this bone stuff, I think I showed this in some other videos, but this is clearly some sort of bone. And they claim that there is no bones in Connecticut. A fossil has never been found in Connecticut. And I can understand when they say there's no calcium bones, like the ones in the deserts and things. They've already been stripped of all the fascia and all the organics. The things have eaten them right down to the calcium. That's all that's left is the mineral. And it just weathers into the ground and doesn't, nobody wants it. This here, what happens is it's covered with fascia. The idea here is we believe these things were, well, I believe it, I'm the one that's doing it, but I don't think anybody else believes it, to be perfectly honest with you. But these, I think, are bones. I mean, I can't believe they're not bones. And they're right here, found here in Connecticut, in these mud conditions. And I believe, and again, it's speculation, but I have evidence to prove what I'm saying, or at least to support it, that the fascia coating that coats all your bones, your organs, your muscles, your tendons, your skin is keratin covered, and it's not water soluble. So it protects it in these wet, compacted mud flow anaerobic conditions. They're not going to go away. They're just going to stay there. And then the nucleophilic process takes over, which is the electrical replacement. And I'm doing those tests right now. All right, look at that round structure in the center. And there's a center piece that has all those little pock marks in it. And then around that it has a cylinder-shaped enclosure. I believe that's a vein or an artery, and this is a dry specimen. And the reason I believe that is because of that black right there. That black just doesn't show up from nowhere. That is either Fe2, Fe3, Fe2 plus, Fe3 plus, carbon, bone char, one of those things that is from life. It's pretty obvious the two of them are sitting right here together in the same thing. This is called a geode. It's supposed to be part of Earth, just made all by itself. I don't think so. I think that's part of life, and the reason the vein is in that shape is because it's a dry fossil. Mud fossils don't do that. Hold on one second. Here's the difference between the dry and the mud. Is, in my opinion, now again, I could be totally wrong, absolutely 100% wrong, but I don't think so. You just saw what you saw here. Dry and in sandy conditions, I believe you end up with this structure. In mud, you end up with fans. Now, these are garnets. Blood is garnets, is what I'm saying. Now, I could be wrong again, totally wrong. I could be way out in left field, but I don't think so. So you got garnets in here. You've got an obvious vein-looking structure. If you look at all those little pockmarks in there, I believe those are cells that exploded. And that is the total, exactly what you would expect from dying. Every cell in your body, I believe, and again, I could be totally wrong, I don't think so. the gases in that cell explode itself, and you get these little tiny carbon bags. Because I believe, again, I could be totally wrong, but the carbon membrane of cell is carbon, basically. It's fatty lipids, they call it. And I think it's like almost all C's and some H's. But it's like a carbon bag. And that bag, I believe, again, could be totally wrong. But I do know what happens, and everybody I think will agree with this, is as you heat organic matter, which is cellular matter, when you heat it in the absence of oxygen, it gases off. They call it sublimation, vaporization, okay? The contents of those little carbon bags vaporize. They blow out of there, they go away, they sublimate, they turn into literally methane, I believe, natural gas. And they sublimate out, and you end up with the carbon, and that happens at, like, say, 1500 degrees, 2000 degrees, somewhere in there. And the carbon, though, stays because it's the highest sublimation point of anything, and there is no liquid state. It turns into a gas at 8000 degrees. Nothing is left when carbon is left. It's a very strange element. But anyway, this is the structure that you'll have in sand and soil, because it doesn't wash out the things, apparently. I'm not sure, but that's what I've found. Now, here's one that comes out of a mud fossil, and that's what I'm saying. This is the kind of I don't know if you can see that at all, to be honest with you. But you get these fan-looking structures. That's because the blood and all the gases wash out of there. They don't just coagulate and stay in there. I think. Again, could be totally, absolutely wrong. I believe this is one of those enthesis points. Again, I don't know, it's crazy. But I think there's one under there, and there's one right under there. And there's like the ball of one that it's going into. But that's the kind of thing you have. Now, on the outside, I don't know if you can see it or not, but there is that fascia. That fascia's on it, that fabricy fascia. That's all I can tell you. That's what I find.